Hey everybody. All right, so we're looking today at limiting reactant or limiting reagent questions. That is stoichiometry questions. So you have a balanced chemical reaction and you're given certain amounts of both reactants or all of the reactants. What you have to do first is find out which is your limiting reactant. So which one is going to get used up first according to the ratio of the chemical equation. Usually you're not going to have the exact ratios present in the reaction. Usually there's going to be an excess of one. And so when you're given a situation where you have amounts of both reactants, you have to determine which one is limiting first and then use that amount of the limiting reactant to as the basis to find out the amounts of all the other products that you get, for example. So in this question, this is just like number one in your assignment, and I will show you that question on your assignment. It's exactly the same, except I've got different numbers here. As you see, I'm going to have different numbers here. So, all right, let's do this question here, okay? So given the following reaction, which is not given apparently, balance the equation first. Okay, well, maybe this is all we're given here. All right, there it is. It's actually, it is in your assignment that you're given there. So this is it right here. So we have C3H8, and we have burning in oxygen, okay? Produces carbon dioxide and water. So this is a combustion reaction here. This is methane, ethane, propane. It looks like here C3H8. And anyways, we have to balance first, okay? So let's balance first. Check out the carbons. There's 3 on this side, and there's only 1 over here, so I'm going to put a 3 there to balance the carbons, okay? Now that has affected the oxygens, but because oxygen is all by itself, that's the one we usually leave till last, okay? Because you can always put a number there and finish it off. So let's take a look at the hydrogens. I have 8 on the left side and only 2 over here. Let's multiply this by 4 now, you see that? To get 8 hydrogens. So carbons, hydrogens are both balanced. Let's check the oxygens now. So on this side, I have 6. 3 times 2 is 6, and 4 times 1 is 4. So 6 and 4 is 10. I can put a 5 right here. Okay, that's a 1. 1, 5, 3, 4. Okay, so that looks to be your balanced equation there. Okay, 1, 5, 3, 4 is correct. So if we have 24.4 grams of C3H8, and 6.708 liters of O2, what's the limiting reagent? Okay, so this is how you do this. You first of all, always in stoichiometry, remember the first rule is convert to moles. So convert everything to moles. So 24.4 grams of C3H8, how do I convert that to moles? But divide by grams per mole of C3H8. How do I find grams per mole? Easy. I take 3 carbons, that's 3 times the mass of carbon that you would find on the periodic table, and you add that to 8 times the mass of 0.794, the mass of hydrogen that you would find on the table. So we add that up and we do this division. So I'm going to do 24.4 divided by this sum right there. Let's take a moment and just do that on our calculator. All right, so you see that we have 0.55333 moles. So 0.55333 moles. And that's going to be of C3H8. Now you don't have to write your units and what it is of every time, but, okay, you probably should, because I've seen many students just go from one number to the next, and then all of a sudden, I have no idea what this number represents. Is it mass, is it grams, is it liters, is it grams per mole? Who knows? So write down your units, do yourself a favor, it takes 0.3 seconds extra, it's no big deal. But now I know exactly what I have. That's what I have in moles of propane here. Methane, ethane, propane. Keep forgetting that. So that's the moles. Now, why is that important? Well, you're going to need to use this moles to compare it with the number of moles of oxygen. How do we find the moles of oxygen? Well, we take the liters of oxygen and we divide it by the connection, the ratio of moles to liters at STP is 1 mole is 22.4 liters. So we're assuming this is at STP, 22.4 liters per mole now. See that? So if you do that, little, let's clear that part. So 6.708 divided by 22.4 is 0.29946, okay, 0.29946. That's moles of what? O2. Okay, so we're close, okay, we're close. Now this is the total number of moles that we are given in the question of oxygen. This is the total number of moles that were given in the question of propane, okay, methane, ethane, propane, okay, 3 carbons. So do I compare these numbers? Not exactly. Why? Because what's being used here in this question is a 1:5 ratio of propane to oxygen. Okay, this is like you're barbecuing propane. Okay, you're barbecuing. So there needs to be 5 parts oxygen to 1 part propane. So how we do that, and there's many ways of doing that. This is the best way I think to do this, is you take what you're given in the question in moles and you divide it by the coefficient for that compound. And what does that do? Well, that kind of gives you a unitary rate, okay? Like it kind of gives you the base rate from which to calculate, the ratios between the two. That's what I always do. So this is 0.5533. Now we're not going to necessarily use these numbers later, but for the purposes of finding limiting reactant, I think this is the easiest and best way to do this, okay? So this is my go-to way. Now divide this by 5, and again, you get sort of this unitary rate. Okay, so what is 0.299? Okay, I've got it up there. Awesome. Divided by 5 is 0.05989. 0.05989. Okay, so this is 0.55, right? 0.55, and this is 0.05. Okay, obviously this is quite a bit smaller. See that? Quite a bit smaller. Therefore, O2 is limiting reactant. Okay, that's how you know. Because if we go back, another way to look at this would be, if you're given this right here, okay, 0.55, let's multiply this by 5 to get the number of moles of oxygen that we would need to fully react with this. So 0.55, right, 0.55333 times 5. I need 2.7 moles of oxygen. Do I have that? Absolutely not. I do not have. I only have 0.299, see? I need 2.7. So this is definitely the limiting reactant, and this is another way to tell. Okay, that is question A. All right, convert to moles, divide by the coefficient in the balanced equation, compare those numbers. The smallest one, that represents the limiting reactant, okay? Don't just circle this number and say, boom, I'm done. No. This number represents oxygen here, oxygen, as the limiting reactant, because it's going to run out first. All right, here's where we get to the good stuff, right? So now what we want to do is we want to find out how much carbon dioxide should be produced. Well, I'm not going to use this number at all for this part of the question, because not all of this is used, remember. This is completely used up. It's the limiting reactant, so I base my calculations on this, the moles of oxygen. It's the limiting reactant. That's the one I use. So I would go from oxygen all the way to carbon dioxide here, and that conversion is going to be the number of moles that are used up, so 0.29946 moles, times the ratio is 3 to 5, okay, for carbon dioxide. So I multiply by 3 divided by 5. So when I do that, so let's go back to this number, 0.29946 times 3 divided by 5. So 3/5 of that, you see, 3/5 of this is what I would need to match that 0.179, 676. 179,676. And that's going to be moles of CO2. It's not what I'm asked for. I'm asked for liters of CO2, so that's no problem. I take this number and I multiply by 22.4 liters per mole. So let's do that. Times 22.4 liters for every mole. So I've actually got 4.02 moles to liters, times by your ratio there. All right, so 4.02, what's the sig figs? Okay, sig figs, 3 and 4. So I need 3 sig figs, that's 4.02. 4.02, and that's going to be liters of CO2 is produced. Boom. Hope you're with me so far. So that's A and B. And I would like to do C. Now C is possibly the trickier one of the three. A lot of your questions will be just dealing with these two aspects. Here's the third one though. You might get a question like this. How much excess reagent remains? It'd be nice if I spelled reagent correctly. Reagent. How much, and reagent and reactant are the same thing. Okay, so here's where we go back to A, okay? And we say, this is how many moles of C3H8 I actually have present in the question, correct? This is how many moles of O2 I have present in the question. I realize that O2 is my limiting reactant, so I'm only going to use 0.29946 of these moles of O2, right? And how many moles of propane am I going to be using with this? Well, this, remember, is a 5-to-1 ratio. So I'm going to go 0.299 right here. I'm going to go times 1 divided by 5. So to calculate this, I do times 1 over 5. That's how I get this number right here. So 0.29946 times 1, and I need to do that divided by 5. 0.0598. 0.059892. Okay, so this ratio, 0.299 to 0.059, that's the same as 5-to-1, or 1-to-5. So that's good. So this is how much is going to get used if all of this gets used according to the ratio. Okay, 1-to-5 is the same as 0.059 to 0.299. Got it? But I have a lot more than this, right? Because this is it's the excess, right? It's the excess, this one. Now, how much excess? Well, if I'm given in the question 0.55333, so 0.55333, and I'm only using 0.059892, I simply subtract those two, and this will be the number of moles, remember this is moles, of excess reagent. So 0.55333 minus the answer from that previous calculation there, I get 0.4934. 0.4934 moles. And sig fig's at what, 3? So 0.493 moles. Now that's the answer in moles. If you're asked for grams, well, then you gotta multiply by grams per mole of propane there, that's C3H8. And if you're asked for liters of propane, because it's in a gas form probably, then that's easy. You multiply by 22.4 liters per mole. So there you go. You can go to grams if you want. You can go to liters if you want. Okay? So that's your example question for the first question on your limiting reagent practice assignment. So here it is. Here's your limiting reagent practice assignment. And these are the numbers that you're going to use for your actual assignment. So I would encourage you to go ahead and give that a try for your actual assignment.